Are we done in this? Yoga Srivatsan, you didn't punch down.
I did, sir.
It is not showing. Dr. Surya Mishra. Done, guys.
Yes, sir.
This is a small table you can find in our book as well. Just I am giving you the table and I'll explain the process. Like in this table, what you will be having is like when functions both are even, what is sum, what is difference, what is product, what is division, what is composition, everything. So like you have the columns here. So column number 1 you take as function f of x. Column number 2 you take function g of x. When we add them, that is f plus g. Subtraction also, it won't change anything. F plus minus g. Now this is f into g, product. Multiplication also same thing you will get as division, f by g. Composition, f composition g or g composition f. Any one thing you can mention, that will do. Not necessary to mention everything, right? So like when we are taking two even functions and we are adding them, right? So even and even. Adding or subtraction of two even functions, we will get even again. You can take, for example, like maybe you need any explanation under this. You take minus x is equals to f of x and g of minus x is equals to g of x. Now you call the required function as h of x. H of minus x is equals f of minus x plus minus g of minus x. From the above property, I can write this is f of x plus minus g of x. Clear? So therefore it is even. Same thing, you multiply them. You divide them, right? You do the composition. See, like in composition case, I have given an example. When any one is even, you will get automatically even there. That I'll give you proper argument there. You can write all are even. Even here, and this is also even. If you want, you can write G composition F. We are writing this one under the assumption where the composition is defined. Right? So next, if I take one is odd in this, even and odd. One even and one odd. Can somebody tell the security about the AC? What he told when you went?
Yeah, I can.
Huh?
In the old list, then we are not here. Or is
Not
it
there.
one?
Not there. Somebody tell him. So like one even, one odd, if we are taking the sum, we will say, or the difference we will say is like neither even nor odd. NENO shortcut I am using. Like you can take, like for example, f of minus x is equals to f of x and g of minus x is equals minus g of x. Now you take the h of x, h of minus x directly we are doing. H of minus x, we will be having f of minus x plus g of minus x. Maybe addition situation you take, we have like this is equals to f of x minus g of x. Now I am not sure whether it is equal to h of x or not. For all values of x, it may not be equals to h of x. That's why we will say it is neither even nor odd. Sum and difference won't be even or odd in this case. Multiplication and division, I can give you like we can say we are multiplying one positive and negative. Even stands for positive, odd stands for negative. Plus into minus, we will get minus. So that's why product is odd, division is also odd. Composition, if you are doing, like I'll give you for an argument for composition. So like we know f of minus x is equals to f of x, and then we know g of minus x is equals to g of x. Let's say we are interested in composition h of x, that is f of g of x. Like h of minus x, we are finding that is f of g of minus x. Since g of minus x is equals to minus g of x, it becomes f of minus g of x. G of x is odd function. F of x is even function. This becomes f of g of x. Therefore, it is even. In composition case, if at least one is even, the composition will be even. Clear? See, like if you can easily prove in multiplication case, just you multiply no f of minus x and g of minus x minus 1 into f of x into g of x. Division also minus 1 will be coming there. That's why they are odd. Now interchanging them, starting with odd and then next is even. If we do in that case, what we will get like, again, we cannot say anything for sum and difference, but remaining we can say here. Let's take odd and then even. In this case, sum we will be having neither even nor odd. We cannot tell anything like it won't be even, it won't be odd, right? Next it is like f into g. If I'm taking one odd, one even function, I'm multiplying minus with plus, I'm getting minus, so outcome is negative, that is odd function, right? Same thing, division also outcome is minus. Here I will get even. Very simple, I can tell here like since both one is odd and one is even, like maybe let us write f of minus x is equals to minus 1 into f of x and g of minus x is equals to g of x. So I have taken the given f and g nature and then I'm finding f of g of x nature. This is the h of x. Now replacing x with minus x, h of minus x is equals f of g of minus x. So like since g is a even function, this becomes f of g of x, right? Therefore it is even. Clear? Now when both odd case we are taking, when we are considering both the functions as odd, in that case, what we get? Like we will see in this, we can say what is our sum and what is our difference. So let's take odd and odd. Two odd functions, adding I'll get odd function, subtracting I'll get odd function. When I'm multiplying minus into minus, I'll get plus. Same thing when I'm dividing minus and minus, I'll get plus. But composition is odd. Like here I can say one thing. When we are doing composition between two functions of even and odd type, the resultant will be even if at least one of them is even. Clear? Understood? Copy this table. After copying this, we will see periodic functions. Maybe if you want some model problems on this, you can try these all things. This is an odd function. You can prove that using the odd function definition. Log x is neither even nor odd. You can try at home this one, maybe homework some, right? You guys punch downstairs. ID? Why? Where is ID card? Not given. Forgotten. See, if you punch downstairs, the attendance will be automatically showing here. Since you didn't punch, I need to check and then mark. We'll do that. Right? Done? Now we are seeing about periodic functions. In physics, some chapter you would have seen sine wave and cos wave about the time period. Similar kind of things. In simple words, we can say periodic function is a function which repeats the values after certain time interval, after certain time period. So mathematically, we will say a function defined on set of real numbers is said to be periodic if there exist capital T greater than 0 such that f of x plus t is equals to f of x. So here two things you need to make sure about t. First one is like t belongs to domain of the function and t is independent of x. T is not depending on x. Clear? So like now, for example, if we are taking f of x is equals to sin x. Set of real numbers to set of real numbers we can take. Now t is equals to 2 pi you take, and then we know very well f of 2 pi plus x is equals to sin 2 pi plus x sin 360 plus theta is sin theta. So this is f of x. Now 2 pi is greater than 0, positive real number. 2 pi is independent of x. And 2 pi is in the domain of the function, right? This implies x is equals to 2 pi is a period of f of x is equals to sin x. Right, any real function defined on set of real numbers will be periodic if there exists a positive real number t such that f of x plus t is equals to f of x. Here t should be from the domain of the function, t is independent of the x. Then the function is periodic function. Clear? Now one another small definition is there. You guys copied this. Can I scroll up? Everybody? Online students scrolling up. So like this is about fundamental period. We say the smallest possible positive value of t is called the fundamental period of f of x. See in the sin x example only guys, same example only. I can also take here, listen please. I can also take here t is equals to 4 pi and I can write sin 4 pi plus x is equals to sin x. So 4 pi is also period. That means there are infinitely many t values we have in the domain, right? In those infinitely many t values, we will consider the smallest possible positive value of t, that is known as fundamental period of the function. Clear? Right? If that is not exist, we will say does not exist only. There are some function for that it is not existing. Copy this. Any doubts in periodic functions in the definition?
Yeah.
T should be positive. So now tell me one by one who is here. Yoga Srivatsan is here. I think I marked your name. Srinivasa and Venkatesh are here. What happened? Copied. Now let us see some standard functions and their fundamental period. After that, we will go into the properties of periodic functions. Again, a table. In this table, what we will see is a function and the fundamental period. In one column, there will be a function. In another column, there will be a fundamental period. So like in column 1, I am writing function f of x. Second column, I am writing fundamental period of the function, right? So first you can take sin x, tan x. Sorry, tan I cannot use. Tan is different. Sin, cos, secant, cosecant x. These four functions are periodic. Fundamental period of these four functions is 2 pi, right? 2 pi is the smallest possible value. You can take 4 pi, you can take 6 pi. Those are all periods of the function, right? Now, second, if I'm taking like, let's say, I'm taking remaining two trigonometric functions, tan x and cot x. These two also periodic, but fundamental period is pi here. You can see tan pi plus theta is tan theta. Using that, we can say this. Now, in third one, let's say we are taking power n of this. Maybe before going power n, let us write modulus. Modulus of sin x, modulus of cos x, modulus of tan x, modulus of cot x, modulus of secant x, and modulus of cosecant x. Again, these all are periodic functions. Fundamental period of these functions is pi. Clear? Now, let us say we are taking power n to the trigonometric functions. Now, sin power nx, cos power nx, secant power nx, and cosecant power nx. So like this one has two cases, guys. Case 1, you will get a 2 pi as the fundamental period whenever n is odd. You will get pi whenever n is even. Now, doesn't matter whatever power you are taking, tan power nx and cot power nx will be always having fundamental period as pi. Now, one more function is there. I think this is the last one I can say. Sixth one. In sixth one, what we can say here is like, if I have x minus greatest integer of x, that is fractional part of x, fundamental period is 1 for that function. You see the graph, all are parallel lines. In between 0 to 1, you will be having them. Clear? If you see the sine graph, 0 to 2 pi one cycle it will be there. After 2 pi to 4 pi another cycle, and so on it will go. Clear? Tan, if you see the graph, minus pi by 2 to plus pi by 2, there is a cycle. Right, pi by 2 to plus 3 by 2, there is another cycle. And so on, the cycles will repeat. Right? Any doubts in this? Can I scroll up? Now we are seeing the properties of this periodic functions. In proper, yes, please, some doubt. Fundamental period, like I have given one definition, the smallest possible positive value of t is called fundamental period. I have taken one example. In this example, function is sin x. For t is equals to 2 pi, I am getting sine of 2 pi plus x is equals to sin x. For t is equals to 4 pi, again I am getting sine of 4 pi plus x is equals to sin x. Out of these two, between 2 pi and 4 pi, the smallest value is 2 pi. I am taking that one as a fundamental period. It should be a positive one. I won't take the negative one here. Clear? Next we are going properties one by one. In properties of periodic functions, property number 1, if f of x is periodic, with t as fundamental period, then a sequence I am writing one by one. 1 by f of x, comma, root f of x, comma, a into f of x plus b, comma, f of x plus a are also periodic with same fundamental period. Now here, listen, there are restrictions. In 1 by f of x case, f of x is not 0. In root f of x case, right? F of x should be greater than 0, right? So now if I am taking f of x is equals to cos x. Now maybe any one I can do here, right? So if I'm doing like f of x is cos x and capital T stands for fundamental period is equals to 2 pi, we all know very well. Now f of x plus a we are doing, that will be cos of x plus a. Now we are finding the fundamental period for this. Like now if I'm doing like f of 2 pi plus x plus a, this will be equals to cos of 2 pi plus x plus a. Right, this entirely you consider as theta, right? Cos 2 pi plus theta, you will get cos theta. It won't change, like unless until we are making the change in the domain. Making the change in the domain, I mean, we are multiplying something to the variable x. If you see in everything, we are not multiplying anything in the variable x, right? Reciprocal we have taken, square root we have taken, a into f of x plus b we have taken, f of x plus a. We are not making any change in the domain as of now. Maybe if you want another example, you can take like f of x is equals to tan x, right? Here t is equals to pi, we know. Now a into f of x plus b is equals to A tan x plus P. So here also the fundamental period won't change. We will get phi here. Clear? This is the property number 1. Copy this one. Copied. Then second property. Yes.
Maybe second one. For maybe did not have public plus P.
No, like here you take f of x plus t and prove you will get pi only. Same fundamental period you will get. There won't be any change. We can prove that. Right? See, like what you need to prove here, everything will get cancelled. Maybe if you want, listen. This function you assume as g of x entirely. Right? G of x is equals to A tan x plus B. Now you need to find the t value such that g of t plus x is equals to g of x. You are making, right, replacing x with x plus t. If you do that, what you will get? You will get a into tan x plus t plus b is equals to a into tan x plus b. Both side b got cancelled in step number 1. Both sides a got cancelled in step number 2. You have tan x plus t is equals to tan x, right? This implies t is equals to y. If you want, you add this one for that argument, right? Now in second property, same first line again. If f of x is periodic, with t as fundamental period, then f of ax plus b is a periodic function and fp is equals to t divided by modulus of a. When we are multiplying something to the variable x in the fundamental period, you should divide that one, right? So like the multiplication thing can be negative. Since the fundamental period is positive thing, we are making sure t by modulus of a. Clear? Understood? Now, if we are taking some examples on this, like let us take a function f of x is equals to 2x minus greatest integer of 2x. What is this function? This is fractional part of 2x. Now, we know that f of x is equals to greatest integer of x is periodic and fundamental period of that function is equals to 1. I am multiplying 2 to this, right? If I am multiplying 2 to this, like I can say that g of 2x is equals to fractional part of 2x is periodic, but there is a change in fundamental period. Fundamental period becomes 1 divided by how much you are multiplying. Clear? So fractional part of 2x is also periodic, but the fundamental period of this one is 1 by 2. For example, instead of multiplying, we can also have in division. Right now, let us take sin x. We know that f of x is equals to sin x is a periodic and fundamental period is 2 pi. Now, what about f of x by 2? F of x by 2 is sin x by 2. This is also periodic, but fundamental period becomes 2 pi by 1 by 2 I should write, guys. What I am multiplying with x there? I'm multiplying 1 by 2 only, no, to my x. So that's why I should divide how much I'm multiplying. Clear? So like in another way, if we are talking, when you are multiplying to the x, you should divide to the fundamental period. When you are dividing to the x, you should multiply to the fundamental period. So like this becomes t will be equals to 4 pi. If you want, you can check it. Maybe let us add this one also. One line I have left, no? F of x by a is a periodic function and fundamental period is equals to modulus of a into t. Right? In this way, what you are doing for x, you should do reciprocal to the fundamental period. If you want, you can check in the second example. Right? You replace and then try checking here. If I'm replacing like how much is f of 4 pi plus x by 2, I need to do this. So this will be sine of 4 pi plus x by 2. So how much is this? This will be equals to sine 2 pi plus x by 2. So now 180 plus theta is sine, sorry, 360 it is x by 2. Clear? Understood? This is second property. Any doubts in this? Now in first property, when there is no change in the domain, fundamental period won't be changed. When there is a change in the domain, there is a change in fundamental period, right? Now the third one we are seeing, can I scroll up? Anybody writing this?
Sir,
Yes, please.
sir, why we take that f of x by 2, sir? In the t is equal to 2 by only. Then why we take f of x by 2?
See, like I'm giving one example, I'm showing you how it works. Let's say if the function f of x is sin x, in that case, the fundamental period is 2 pi. Now, when I'm changing the function sin x as sin x by 2, in that case, the fundamental period becomes 2 pi by 1 by 2, which is 4 pi.
Okay, sir.
Hmm. Everybody copied this? One moment, I'm marking. What is your name? Ajay. Ajay Kannawar.
NS Ajay Kannawar.
NS Ajay Kannawar. Now the property number 3. In property number 3, if f of x and g of x are periodic functions, with t1 and t2 as fundamental periods, then f of x plus g of x is a periodic function and fundamental period is LCM of t1 and t2. This point is not valid if LCM between t1 and t2 is not defined. This point is not valid if the functions are interconvertible functions. If f of x and g of x are interconvertible functions like sin x, cos x, then the above property may not works. There are some restrictions for the above property, right? So now, for example, if I'm taking, first I'll give you an example where it works, then I'll give you an example where it won't works. F of x is equals to sin x plus cos x. Here it will work perfectly. There is no doubt in that. Like two functions are there in addition, sin and cos, LCM between 2 pi and 2 pi if I do, it is defined that is equals to 2 pi only, right? Now, if you want to show that, you can also write this one as multiply root 2, divide root 2, and this is 1 by root 2 sin x plus 1 by root 2 cos x. And then like this bracket, we can write as root 2 into sin x plus pi by 4. Now using the property number 1, I can say that f of x is periodic and fundamental period is equals to 2 pi only. There is no doubt here it is working. Now where it is failing. Now let us take an example. Second one, let's take f of x is equals to mod sin x plus mod cos x. Clear? So in this case, what is happening? Right, mod sin x and mod cos x. Both are periodic. Fundamental periods for them are pi each. LCM of pi if I do, I'll get pi. But here, my claim is there exists a smaller positive real number where I can show that mod sin x plus mod cos x is equals to again modulus of sin x plus t plus modulus of cos x plus t. I can prove that, right? What is that t value? Now, as per the above property number 3, I should get pi here. But my claim here is like, if I take f of x plus pi by 2 in this, what I'm getting modulus of sine x plus pi by 2, modulus of cos x plus pi by 2. Now we know very well sine 90 plus theta is cos theta, cos 90 plus theta is minus sine theta. Even though it is minus, modulus is there, that will be changing it and we'll get mod cos x plus mod sin x. Clear here it is failing, no? In this case, the fundamental period is equals to pi by 2, not pi. Pi is a period, we'll agree, but that is not the fundamental period.
How will I take? First example. System, yes.
Multiply, divide root 2. Sin x cos pi by 4. Cos x sin pi by 4. Sin x plus pi by 4. From the property number 1, a into f of x plus b is periodic. Fundamental period is same. Clear? See, like we don't have properties when we have functions in multiplication and division. In that case, using the trigonometric identities or trigonometric formulas, we need to make them as in addition or subtraction. Clear? Another example, in this case, like when functions are interconvertible, we need to be little careful. When they are not interconvertible, there is no worries, right? Here you need to take note that LCM of T1 and T2 is not always defined, right? Maybe I'll write that. Anybody copying this note point? Everybody copied. So like now write this one. Note for third point. LCM between T1 and T2 is defined if T1 by T2 is rational. Right? When the ratio between T1 and T2 is rational, in that case LCM is defined. Now in this I didn't give any example. No, let us take one example where fundamental period is not defined. That is not periodic, I mean. There does not exist any such value of t. F of x is equals to sin x plus greatest integer fractional part of x. Now two functions are there in addition. T1 is equals to 2 pi. T2 is equals to 1. See, like LCM between 2 pi and 1 is not defined because LCM between one rational and one irrational we cannot find. LCM between two rationals we can find. LCM between two irrationals also we can find only if they are of same type. Pi here, pi there, root 2 here, root 2 there. In that case only I can find one pi and one root 2. I cannot find LCM. For that only I wrote this point. Now here LCM of 2 pi comma 1 is not defined. If this is not defined, we can write f of x is a periodic function. A periodic function, that is not a periodic function. Any doubt in this, anybody? Some doubt? NS Sajay Khanna?
Yeah, T1 and T2 are both new.
Where? Sin x.
Sin, mod sin x.
No, not one. That is pi. Did you wrote like that? You're talking about this table only, no? See, this is 2 pi. This is pi. This entirely is pi. Right? Yes, please. I explained, no? See, this is an exception thing. In this case, property number 3 fails. I have mentioned that we need to be careful when the functions are interconvertible. Mod sin x plus mod cos x is periodic, but fundamental period is not pi. That's what I am explaining here. For that, I have taken pi by 2 and I have proved it. Clear? I think this is property number 3 we have seen. Okay. Property number 4. If f of x is periodic, and g of x is any function I mean it can be periodic, it may be aperiodic. Then G composition f, that is g of f of x, is periodic. If you want the composition to be periodic, make sure the inside function is periodic. I didn't mention anything about the fundamental period, it changes, right? So we can take one example here. Example number 1, function f of x is equals to cos x, we can take g of x is equals to a power x, we can take. Now, what we can say? G of f of x, right, is equals to how much we will get? A power cos x. Now, this one you call as h of x. H of x plus 2 pi will be equals to a power cos x plus 2 pi cos 360 plus theta s cos theta. So a power cos x, which is equals to h of x. This implies h of x is a periodic function. Yes, may or may not. Not necessary, no. A power x is not periodic. I have taken. You can take one periodic as well. Now, another example I am taking. Here you may be arguing, sir, fundamental period is same. Now, I'll give you an example where fundamental period is not same. Let's take f of x is equals to sin x and g of x is equals to modulus of x. Modulus of x is not a periodic function, that is a periodic function. Now, if I am taking like g of f of x, this will be modulus of sin x. See, like modulus of sin x is periodic, but fundamental period is not equals to sin x, right? That's why I didn't give any. Fourth one, copied. Fifth one,
Second one is not period.
which one? Periodic only. Fundamental period is changing. Mod sin x is periodic only. Time period is pi for mod sin x. For sin x, it is 2 pi. That is changing is what I'm. Now these are all examples where you won't get periodic. Like, let's say if f of x is periodic, then f of root x is not periodic. You can take as an example, sine root x is a aperiodic function. Whatever. Now in the book, there are some problems on periodic functions.
So, if f of x is periodic, then root of f of x is periodic, but not f of x.
See, like problem number 32. Page 21 exercise. Page 21 exercise problem we are talking, problem number 32. Not sure. Answer I didn't remember. How you are telling pi? Sine power 4 and cos square are interconvertible functions, right? Now, what is my claim is it is not pi. How to prove that? We will do that. Given function f of x is equals to sine power 4x plus cos square x. Now, using 2 theta formulas, this is 1 minus cos 2x by 2 whole square. Everybody understood this? Plus 1 plus cos 2x by 2. Now again, this is 1 by 4 plus 1 by 4 into cos square 2x minus 1 by 2 into cos 2x plus 1 by 2 plus 1 by 2 into cos 2x. These two terms gone. Remaining is 1 by 4 plus 1 by 2 is 3 by 4. Now plus 1 by 4 into, we are writing 1 plus cos 4x by 2. Like this is 3 by 4 plus 1 by 8 plus 1 by 8 into cos 4x. Now this will be equals to 1 by 8 into cos 4x. How much is, I think this is 7 by 8. Now you see this function, it is in the form of a into f of maybe bx plus c. So a and c is not creating any harm to the fundamental period, right? What is creating na, that is inside b, right? Now I can say fundamental period, unless until they have mentioned they are talking about fundamental period. Fundamental period will be cos x fundamental period you take, that is 2 pi. Since 4 is in multiplication, I should divide here, right? This implies f of p is equals to pi by 2. We can prove this. Clear? Any doubt in this? Anybody? When the functions are interconvertible, care need to be taken. Online students, any doubts in this? No, right?
Sir, why 2 pi by 4, sir?
Sorry.
Why we took 2 pi by 4, sir?
See, like, listen. Fundamental period of cos x is 2 pi. Fundamental period of cos 4x will be 2 pi by 4.
Okay, sir.
Anything else, online students?
No, sir.
See, they will give you some functional relations or functional equations. We need to find the fundamental period. I'll give you like some problems we'll solve on that as well. Where function would be given, just functional equations or relations will be given. We need to calculate the fundamental period. Page number 37, problem number 30. So they have mentioned that f of x plus 10 plus f of x plus 4 is equals to 0. Then they are asking us to calculate the fundamental period. Fundamental period unless until they have mentioned it. Now using replacement property, I'll try to eliminate f of x plus 10 or f of x plus 4 from this, right? How to do that? Let us replace x by x minus 6. Why I am doing x minus 6? So that I'll be having f of x plus 4. I'll subtract, it will be going, right? So this becomes f of x minus 6 plus 10 plus f of x minus 6 plus 4 is 0. Now this is f of x plus 4 plus f of x minus 2 is 0. Writing equation 2. Now subtraction if I do, right? 1 minus 2 implies that what I will get? F of x plus 10 minus f of x minus 2 is equals to 0. Now I have a relation f of x plus 10 is equals to f of x minus 2. Again, if I can create f of x is equals to f of x plus t, I'm done here. My fundamental period I have. So now I replace x by x plus 2. Now this will be f of x plus 2 plus 10 is equals to f of x plus 2 minus 2, both gone. We have f of x plus 12 is equals to f of x. Now I have a situation where f of x plus t is equals to f of x. That means it is a periodic function and fundamental period is equals to 12. Any doubts in this? In last class, I asked about the Sunday special class. I said there will be a special class if you want. Then nobody asked me, I didn't conduct it. If no students are there, to whom I should teach bench and board? If you show interest, then I'll arrange again. You are not showing any interest. Whom should I teach? Once we finish this chapter, maybe like we will sit again, we'll discuss. Not every chapter from 11th we cannot do now. Maybe few easy chapters we will do now. Some important chapters. We'll all sit and then discuss. If you are saying yes, sir, we will attend, then you has to come. If you are not coming, I'll stop those classes. Clear?
Lagging now.
Sunday timings and all, I didn't decided yet. I want your response, like it changes. I should be free and you should be free, no? Maybe not Sundays. Your schools are reopened. When they are reopening? No, day after tomorrow itself. Then one day we all will discuss once we are done with this. I think in one class we will be done. Tomorrow will be the last. After that, like we will discuss like with everybody. I want your response. Please respond in class when I am asking about this. If there is no support, I cannot arrange anything. Maybe there are some easy chapter in 11th grade, which just like weightage. In JEE Mains, one problem or two problem might come. That chapter we might discuss not from the scratch again. It is like from ground level, I am not taking you to JEE level. It is not possible in short time. What I do is like I expect you to know NCERT, from there I'll take. Clear? One person asking one chapter, na, not possible. Let me clarify regarding limits. Limits you will again see in 12th grade. Limit continuity differentiability is there in 12th grade. Third target, first chapter. Third target, first chapter. At that time I'll teach. Then
Complex number can we teach?
full chapter you want, complex number?
Not
Full chapter. Mad or
What
what? Full chapter not possible.
problem, sir.
Conics, 5 chapters he's asking. Huh? Conics, how many are there, you know? Circles, parabola, ellipse, hyperbola. Straight lines maybe you exclude. 4 are there. Minimum 1 month we will take to teach that entire conics in class. What do you want me to teach in this revision? Huh? You know, and at least NCERT? Then from there we can do some problems. Only no, some guys want concept. No, they don't know anything. At least glimpse I should give.
Sir,
Yes,
I am
please.
state board. I am state board, sir. There is no chapter from conic section, sir.
You will
In
be
11th
having now. Don't worry. In 12th grade, you will be having. You will read it.
Okay, sir.
Conic sections, hyperbola, parabola, ellipse, circle, everything you have in state board as well. They'll teach you.
You saw.
Before itself I was saying. Huh? See, like there are some easy chapter. The chapter name is like algebra chapters. I will start. One is binomial theorem, easy one. Sequence and series, easy one. There won't be too many complex concepts in that. Once you understand, you can solve them. After that, like if you want some easy one, we can say by this one, permutation and combination and complex quadratic. These all things will come, right? But like each chapter at least takes 4-5 classes minimum to see glimpse and model problems, right? So maybe I'll plan one chapter. Let me sit again and I'll let you know definitely in one class. Today one class is there, no? Tomorrow one class is there. Tomorrow I'll tell you in tomorrow's class. I'll plan before that. Online students, I want your thing as well. You should be available, no? When is your school starting? If school is starting now, we can have only on Saturday and Sunday, I guess. Right? That's what, evening only. Maybe let me talk with sirs as well. One day we should decide, and after the day we should decide what chapter we are going to start. So I am announcing now itself. I am not taking from the scratch, right? So don't ask me to take from the scratch. So I expect you know some basics. If you didn't study it in NCERT, what you do is like you learned little from the iTutor or you learn little from YouTube or somewhere. Something should be knowing about it. Then from there I'll teach. Clear? See, like I'm doing some work, you should also do some work. Then only you will get something, or else you won't understand. From scratch, if you are doing in 11th grade, they came for 6-7 months, they learned. In 1 month, we cannot do the entire 11th grade. Clear? Am I clear, online students? I think yesterday somebody messaged me. Kirti Sri is not there, huh? She is there online. Some Shiva Ganesh, I think you also messaged me, right?
Sir, no, sir. I was asking about the doubt class, whether it is
Oh,
there
you
or
are
not.
asking about doubt class only. Then 2 or 3 students messaged me about it. Tomorrow will be last class on functions. That is on domain and range. Right, we will see the model problems, how to calculate. As many as we can, we will do. After that, from Thursday, we has to do, I think schools are starting, 4 o'clock we cannot do. 4 o'clock we cannot do, no? What time school ends? 4:30 only it ends. Your school little better only. Some school will end at 5:30 and 6. Okay, then Saturday and Sunday we need to target, huh? Then I'll take note of it. If you have any problem like this, please let me know. Or else, like if I schedule a class, after that you are messaging me, it won't be good to change or modify at that time. Saturday after 5:30 is okay for you. If I am available, it will be on Saturday. If I am not available, it will be on some other day, Sunday. Right? I'll just let you know what I planned. And then if you are good with that, you can attend. Maybe I have some 5 or 6 students, I'll continue it. Not 5 students, I'll stop it. Clear? Am I clear, online students?
Yes, sir.
Hmm.
Yes, sir.
Then you guys can leave. Start join your next class link. We have maths class today. We will see matrices. I think after types of matrices, addition, subtraction, multiplication, and the properties that we will see today.